Well, hello again everybody. Well, today we're going to be doing an unboxing video, or as I like to call it, a gloating video, where I get to unpack all my precious things and gloat over them in front of you. So let's get on with it. Bought two pieces of equipment that I absolutely don't need, and the reason I bought them is because I was drunk. Don't really need to say any more than that, do I? Because yeah, we've all done that. I don't know what order I'm going to open in. Let's just get one open. I always manage to open these the wrong way up somehow, so I end up with this, I don't know, this shredded paper everywhere. So yeah, I probably did that wrong, didn't I? Oh, fail! Well, we've got an M&W badge on it. Is that enough to get anybody excited yet? It's enough to get me excited. Well, anybody who knows anything about machining or engineering, you're gonna recognise this symbol. It's kind of recognisable worldwide, and it's M&W, which stands for More and Right. Now, I actually found out something interesting the other day. I actually work in Sheffield, in an area called Darnall in Sheffield, amazingly enough. And apparently, if anybody knows Sheffield, and maybe particularly the area around Darnall, there's actually a big Asda's there that must have been built, I don't know, about 10 or 15 years ago. Now apparently the huge factory where More and Right used to manufacture from, they were based in Sheffield. I mean, I've seen their Sheffield name on stuff, but yeah, apparently they used to be based where the Asda is, if anybody knows that. Right, so just before I open up the little More and Right box, does anybody want to take a guess what's in it? I'm going to give you a count to 10. 1, 2, 9. A fingered beauty. So what we've got here is, well, it's what they call an internal micrometer. So maybe to explain that, let's just have a look at an ordinary micrometer. So here's an external micrometer. Now this is probably going to be bleeding obvious to most of you, but the thing about an external micrometer, it measures the outside of things. So basically the way that we would use this is that we would be able to measure the outside of this piece of brass. So basically we would screw these up. Actually, and I wouldn't use this one because it doesn't do that range. Okay, let's find, here's one I prepared earlier. That's a bit bigger, isn't it? So let's say we wanted to measure this. We would put the object that we want to measure, we screw these up, and then we can take a reading off here, and that's an external measurement. But just looking at this piece of metal here, it's got a bore in it, hasn't it? So if we wanted to measure that bore, it would be considerably more difficult. You know, maybe we could try and wind this shut and line it up with it, but that wouldn't really work because this is for measuring externally, not internally. So our external micrometers take a measurement between this face here and this face here, whereas this internal micrometer works the opposite way around. This will take a measurement between this face and this face, so this will measure something internally. And as you can see, this internal micrometer works in just the same way as unscrewing a bolt. You screw it clockwise and it closes up, screws the bolt in, screw it anti-clockwise and it moves out again. And that's really how a micrometer works. Well, it is how a micrometer works. It's really a very simple idea. It's just a screw thread that has graduations around it. So I've screwed this out as far as it will go, and well, it reminds me of a girl from Barnsley I used to go out with. So we've got a problem there. However, the people who manufactured this instrument foresaw that problem. So what they actually allowed us to do is we can take out this, I'm going to call it the anvil, we can take that out and we can get a longer one. So we'll put that in and have another go. So this extended anvil piece has taken up that gap now. So now we can just screw this out until we can't rock it backwards and forwards anymore. Or I believe that's the idea anyway. Now I'm not sure of the best way to hold this. From what I can see by watching other people on YouTube, pretty much every machinist has his own way of doing it, and I guess it's the practice thing. Whatever works for you is probably the best way of doing it. But I'm doing it for the first time, so I don't know what works best for me at the moment. I'm just trying to figure that out. Well, that feels as though it's touching both surfaces there. It does feel perhaps a little bit tight, so maybe I need to undo that a little bit. It's certainly quite fiddly to do that. It seems to be jamming up a little bit. I wonder if a little smidgen of oil would help. I don't know. Okay, I'm just getting a little bit of drag when I move it in and out there, a little bit of a drag between the two surfaces. I suspect it's really easy to get this wrong. And I keep kind of getting it jammed because I've got it a bit stuck there now, so I'm going to have to undo it, I'm going to have to back it off. Okay, I'm going to go for that. So we need to read this now, don't we? So that extended anvil I've got on it says 70 to 90 on it, so I'm guessing that's my measuring range. And then on the graticule here, we're on the 10mm mark. So I'm guessing we've got 70 to start with, plus 10 because we're on the 10 thing. And then on here, on the thimble part, can you see that? I'm hoping you can see that. On the thimble part, I think I've just nudged it. I think we're on the 18, I think we're on 15, there's 20, there's 15, there's 20 at the top. And I think we're on 18. So I'm guessing that is, it's 80 plus 18. So 80.18 millimeters. That's what I'm gunning for. Maybe. Okay, there's a dirty way we can check it, so let's just slide them in. Well, they're saying 80, but yeah. Well, they're saying yeah, it varies. They're saying around 80, 79.96, but a bit wibbly wobbly. Okay, I've got another method up my sleeve here. I'm going to use something called telescoping gauges, and I think you saw me using these in the video the other week when I was making something to go on a bike hub. And what these will allow us to do is they won't take a direct measurement, but basically they will record what this bore is. They will take a record of it, if you like, and then we can actually measure these directly using a normal normal external micrometer. I do hope I haven't been getting the word internal and external mixed up. I think I might have done. Okay, I think that's taken them reading. Okay, so we'll take our telescoping gauge and we'll just put it inside this normal micrometer, and we'll just twist these up, and a bit fiddly to do. I'm going to go for that. So 80.185 millimeters. So basically bang on. And what I've seen some other machinists doing, I've also seen them transfer the actual reading from the internal micrometer to an external one, and I think the way that they do that is I think they hold that, take the handle off it, make it a bit easier. So we'll hold that against there. In theory, hopefully we'll get the same thing. Okay, I got a little bit less that time. I've got 80.16, and I think I was measuring 80.18. So 0.02 of a millimetre out, I'm getting difference between the two measurement techniques, and I'm sure that's just because of my inexperience. Well, I'm feeling terribly smug and pleased with my purchases right now, so yeah, I'm really happy with that.